Hello everyone, today I'm going to discuss about differential calculus, rules for differentiation. So we have different rules. This is the one of the most important rules. So we have constant rule. So if we have let's say a constant there, or let's say a number 1, number 2, or any constant numbers, so it would instantly turn to 0. So the identity function rule is if we have a variable, which is if you have x or y or z that doesn't have any exponents, so it has 1 here, 1, 1. So this would instantly become just 1. Okay. So here we have the product rule. So if you have here, let's say a variable that is multiplied to another variable, the first term is that you have x. So this is x, and this would be the differentiated version of y. So the differentiated version of y is 1, then plus, then we have y, then a differentiated version of x, so we have 1. So that's basically the product rule. And the fourth is the quotient rule. So we have, just remember in the quotient rules, we have lower minus upper over lower squared. Okay, so we have here lower, which is untouched, then the differentiated version of the upper minus the upper and the differentiated version of the lower, then the lower squared. Okay, so here we have the power rule. So in the power rule, we just have, let's say if you have x here and then 3, it becomes 3 minus 1, and the 3 here would go into the x. Okay, and then it's just 3x squared. It's just like that. So here, what is this? The du over dx. It means that let's say if you have x, how do I explain this? We have x plus 1, then we have square there. We have 2x plus 1, then 2 minus 1. Okay, then you have to differentiate the inner part. Okay, you have to differentiate the u. So we have the differentiation of u. So we have just 1. Okay, so we have 2x plus 1 over 2 plus 1. So yeah, on forward with our examples. So our examples, we have y is equals to x cubed minus 4x squared plus 5. So here we have find the dy dx. So dy, in order for you not to be confused, dy dx is just equals to y prime. Okay, this isn't y raised to 1 but y prime. So here we have dy over dx is equals to d over dx, then the equation itself. So we have x cubed minus 4x squared plus 5. Okay, and now let's remember the power rule. So we have x 3x, bring down the 3 minus 1, and then d over dx, you just, let's say, distribute it, and then minus, we have 4x squared, let's bring out the 2, x squared minus 1, then we have d over dx plus 5 d over dx. So here, remember the power rule. So we just to this is equals to 2 minus 4 times 2, we have 8. And x, 2 minus 1, we have 1. Or you can just put x there. And we have the constant rule, which is the 5. 5 is a constant, therefore it should be 0. So you would have 3x squared minus 8x. Okay. On to the next example. So we have y squared of 3x squared. So I'll give you a chance to solve this equation. So here we have dy dx of 3x squared. So d over dx. We know that the 3x plus 2, 3x plus 2 is just raised to 1/2. Okay. So in order to let's say differentiate it, we just use the power rule. So we have 1/2 3x plus 2, then 1/2 minus 1, and then don't forget to differentiate the inner part. So we have 2, which is the constant, so this would be 0, then 3x. 3 times 1, so we have 1 here. Always remember that any variable always has an exponent of 1. So 1 here multiplied by 3, so we have 3. 1 minus 1, so it has 0. Any variable that has an exponent of 0 is equals to 1. So we have 3 times 1, or just 3. So here we could simplify this. So we have 1/2 3x plus 2. 1/2 minus 1 is equals to negative 1/2 times 3. So since it has a negative here, you just bring it to the denominator. So we have 3 over 2 square root of 3x plus 2.